In this problem, we have the following circuit diagram here with an op amp inside of it. We are told to assume that our operational amplifier is ideal, and we are also given this for our voltage. We need to find the steady state output and write it here. We also need to see how large our amplitude VGT can be before it saturates. To solve this problem, we need to look at our op amp, and we know that the part going into our negative terminal is our Vn, and the part going into our positive is the Vp. And our output is our V0, which is what we want to find. And since we have voltage going back this way, we know we're going to have some negative feedback. That's going to be important when we write our node voltage method for it. And we also know that our Vn is equivalent to our Vp. That's going to help us solve for this problem. And we have an unknown here, which we are given this for. So we know we are going to have our 25 with an angle of 0 degrees in here, or for rectangular form, we're just going to have a 25. Now that we know all of this, we can start writing our node voltage method. For our node voltage method, I'm going to start with the Vn. We know we have some current over this resistor, so we are going to have our Vn over our 80 kilo ohm resistor. I'll just write this as 80k right now. We know that we have some negative feedback coming this way because of how it's connected. We have some negative feedback over our capacitor. We have some negative feedback over our resistor. So we have to add these together. We're going to do a plus Vn, and we can see that our capacitor, and we need to convert this into the reactance. So we're going to have that our Z of C is equal to a negative J over our omega C. Our omega is given to us with this 50,000, so we are going to have negative 1 divided by a parenthesis 50,000 times 250 times 10 to the negative 12 for pico. And we are doing this because we want it in just farads, not picofarads. And this is going to give us negative 80,000. But I am going to write it as negative 80k because we know a k is equivalent to 1000. And we are going to have our minus V0 over here because that is the current flowing through this, or that's the voltage flowing over the impedance that makes it a current. Now we also have the resistor here, so we are going to have a plus Vn minus the negative feedback from our V0 divided by our 40 times k, and this is all set equal to 0. Now to simplify this, I am going to multiply everything by 80 kilos. I also made a mistake. I just realized when I solved for this capacitor right here, I forgot to have the J. So this should be a negative J times 80. I'm going to fix that in here. Now we can properly multiply everything by 80k to get rid of everything in the denominator. And this J right here, this negative J, we are going to flip into our numerator when the time comes, and it'll become a positive J. And this will be our new equation. Now we need to find our Vn. We know that our Vn is equivalent to our V of P, so we are going to look at this part of our op amp and solve for it. We are going to have our Vp, but I'm going to write it as V of n, again because they are equivalent, minus our Vg, which is the source. We're going to have this as 25, and this is all being divided by the 80 kilo ohm resistor. We're going to add to this our Vn, which is again our Vp, over our 20 kilo ohm resistor, and set this equal to 0. Again, we're doing the node voltage method for this node as we did previously for this node. Now to simplify this, I am going to multiply everything by 80k. I also forgot a 0 here. Make sure we write that out correctly. But after I do that, we can rewrite this, and this is what we're going to get for our equation. Now we want to find our Vn, so we're going to add our Vn's together. We're going to get a 5Vn, move the constant to the right, and we will get a 25. So that means our Vn is going to be equal to 5. Now that we know our Vn, we can plug it back into here, and then we can also factor this in. So we're going to get a 15 plus 5j, and this is all being divided by our 2 plus j, set equal to our V0. Now we need to convert both of these to the polar form so that we can divide them out. To convert from to the polar form, we are going to have our Vmax equal to the square root of our real number squared plus our imaginary number squared, and then we're going to have our angle equal to the tangent negative 1 of our imaginary number divided by our real number. And if we do this, we are going to get that our answer is equal to approximately 7.07 with an angle of negative 8.3 degrees. And that's how we solve for part A. Now for part B, we are asked how large can our amplifier get before it saturates. To do this, I need to find our V0 max, which is going to be the same as our VGT max. To solve all that, I'm going to put our V0 over our VGT. We know that our V0, if we put this in the polar form, is equal to 7.07 with an angle of negative 8.13 degrees. And this is going to be over our Vg of t, and we know that our Vg of t is equivalent to 25 with an angle of 0 degrees. Now I'm going to rewrite this, however, we are going to plug an additional part in. We are going to note that our V0 t, if it is at the max, because it's asking us how large can our amplifier get right here, we are going to plug in a 10 because we have this 10 volt here and this negative 10 volt here. And I'm actually going to plug in a plus minus 10 volts because we don't know which one is greater at the moment. Now we need to solve for our VGT. So I'm going to take our numbers, divide them, and then I'm going to take our angles and subtract the denominator from our numerator. Now, after I got this equation, I divided everything by what was on our right side here, and then this. That way we can get our Vg of t by itself. So in dividing this, I'm going to convert this to the polar form. This is just going to be 10 with an angle of 0 degrees. And now rewriting this, we're going to have 10 divided by our 0.2828, and this is going to give us approximately 35. And we don't really care about our angle because it's only asking us for the maximum voltage. This is our V max. We know that this will be our V max, and then whatever angle comes out is just going to be the angle. The angle here would be an 8.13, but this is what we're caring about. So if I reveal the answer, we can see that it is approximately 35. And that is how you would go about solving for this problem. If you want more network analysis problems, there's a playlist in the description. If you want notes that cover this entire coursework, they will also be in the description below the like button.